Good afternoon, ladies and gentlemen. Welcome to TechGig webinar series, our endeavor to impart techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight to various domains. The topic of today's session is standard-driven, distributed and interoperable content management systems using Java, J2EE and web services. Our guest speaker today is Jayshree Tangirala, Program Manager, Educational Testing Services, ETS USA. Jayshree brings 19 years of experience in IT industry as well as academia with special interest in application of cloud computing architectures, machine translation, semantic web and machine learning technologies to BFSI, healthcare and education industry. A technical product manager, she combines her technical knowledge with business acumen to implement strategy-driven, cutting-edge products. So without further delay, I introduce you all to our guest speaker. Over to you, Jayshree.
Hello and good afternoon, friends. Welcome to this session of creating an e-learning architecture. We will be focusing on using J2EE and web services. So, my request to all of you is please save your questions till the end, and there will be some time when you can ask me all your questions regarding this presentation and the content that we have discussed in this presentation. Now, this design that we are presenting is an architectural design. So today we will see an overview of an e-learning architecture which is standards driven. That is, it will be standardized and globally applicable and works towards a global connected e-learning environment. Starting off with the presentation, today we will be looking at the traditional methods of teaching using paper-based books, limitations of these teaching methodologies, and then we have dependency on availability of a teacher and so on and so forth. Till date, maybe about 2000 or so, the method of teaching was largely paper-based, on paper-based books, paper-based and paper and board-based books, and you need to have a teacher in order to teach your class or take your class. There were a lot of limitations in this kind of teaching methodology. The main limitation was the physical limitation, where every student had to congregate to one classroom or one room where the teacher takes the class. Plus, there was also a limitation of the number of books available. Sometimes the books got so bulky, there were a number of volumes to be printed of the same book. And there were other dependencies, like whether a teacher is available on a particular day or not. The more specialized a subject, the more specialized the teacher's skills would be, and it is harder to find a teacher to teach such a subject. Apart from these limitations, there was other such limitation, like it could not be widespread education. For example, in the rural areas of the countries, Asian countries, for example, Vietnam or India or China, you could not find a teacher who would go into interiors of a rural area to teach the children there. So education had become a limited scope. It was limited to those fortunate few who were located near the schools. And not everybody could afford to go and study to a faraway school. It could be monetary limitation, it could be physical limitation, distance, etc. So education had become a privileged process. But slowly, with the onset of the internet era, people started discovering that we could use the communication technology, internet and communication technology in education. This has been pioneered, especially in Australia, using the education system there, and then it caught on to other countries also, including United States, Europe, and now all over the world. Now you can see slowly the spread of education through internet or videos, or like we are doing just now, webinars. So we will look at these platforms first that are actually existing, and then we will move on to the topic of what is the standardization and globalization of these platforms. So first we will go to the existing need for this standardized learning architecture. Slowly, as I discussed, there was the shift towards e-learning in all major educational institutions. This was pioneered in Australia, and then it caught on to Europe and Americas, and then it came on to Asia. Now this introduction of ICT-based curriculum at school level was brought about initially to enable the students in the school to gain or explore knowledge through internet. So they were given access to these documents haphazardly, which they can Google or search on the internet, or you can even have installable applications which are installed in the desktop right at the workstation. You don't need an internet connection for that. And the students would actually access these informational documents, and they could learn more about the subject they have been studying. This started majorly at the college level in the major institutions like MIT and Caltech, and then it percolated to all schools also. That was when it was realized that there is a need for a globalized learning material instead of haphazard material. Like, you don't have to search for something in order to learn about it. The student should be recommended what to learn. For example, if a student of physics is doing something on field theory or something as trivial as the laws of motion, the student should be recommended what to learn, what further to study, where he can find it, what all to log on, etc., etc. Now, all this is not possible in internet. For example, if you want to search something on the laws of motion on the internet, you will first open Google or your favorite search engine, Bing, Google, whatever it is, and then type in the words, the 3 laws of motion, right? Then it will throw up a lot of documents, which are HTML-based documents, that contain these words as the keywords. Now, there is necessarily no correlation between these 3 words and the topic discussed there. It could be a story that is called the 3 laws of motion, but it will still be thrown up in your search. So, this is not relevant to your search. What we are doing right now is an arbitrary search. There is no recommendation. You are actually using your own resources to search for these 3 laws of motion. Unlike this current scenario that I presented to you, how would it be if a student, let's say a student of a school-going child, if he is recommended, look, you have to study these documents first. These are most relevant to your level of knowledge. They are not too scholarly, they are not digressing off the topic, they are just right for you. The student would feel really wonderful in reading these documents, and there would be joy in trying to research and learn more about this particular subject. So that is where we feel the need for a globalized learning material where it is compiled and brought together and recommended to the searcher, the person who wants to learn. In this session, we will be addressing the students or the people who want to learn as the learners. We will also be addressing the objects that are used to impart learning as the learning objects. Now, the learning objects could be books, documents, papers, videos, webinars, or even audio lectures. Now, slowly as ICT caught on, that is Internet and Communication Technology caught on, people began creating their own systems to deliver the education. It could be need-based development of the system. For example, let's take an example, university. This university had the need of combining a hybrid model where the classes are taught in the classroom by a teacher, but there will be some extra lectures given on the weekends. Now these weekend lectures could be given through either an audio system or a video system like the webinar that we are using, GoToMeeting, or something totally different where 4 people come together and the teacher sits on his own computer, he logs on to the Skype or some such meeting, MSN meeting or such meeting application, and then he could teach these 4 or 5 students or the group of students who will be signing in. It all depends upon how evolved the lecture could be. On the flip side, there could be a university which doesn't have any classrooms at all, but it only imparts knowledge through virtual media, which is through webinars or through internet. So they have a need for a highly specialized application where the students can interact with the teachers. Sometimes they might want to actually see the teacher's face while the lecture is being delivered so that the impact is greater. Then the teacher may feel the need of demonstrating some application or some experiment if it's a chemistry or a physics or such subject. And there could also be a need for the students to ask questions and the teacher to answer. Now that could be in between also or at the end of the session. Just like as I said at the beginning of this session, I'll take all your questions at the end. But there may be a session where the need is right in the middle or as and when the topic is being taught. So it all depends upon the need for the university or the need for the educational training institution. So different kinds of information models working with e-learning environment have cropped up. Each has its own environment depending upon the legacy systems. Each has its own requirements and its own architecture. Now, all these are existing in their own localized worlds. They cannot communicate with each other. Why? Because of the universal problem of lack of communication between the architecture. When such a situation arose, it was seen that it would be more informational, it would be more advantageous to have these systems communicate with each other. Let us say there's a class or a course going on in MIT and one going on in Caltech parallelly on machine learning. The same lecturer is taking the classes here as well as in that university, which is across the country. However, he has to create the course again for the portal on Caltech, and similarly he has to create the course on the portal for MIT. It doesn't really make sense because he may have to customize the course according to the need of the portal. So that's double effort for the professor. What could have been simpler is if he could have reused the material from wherever he has first delivered the lecture. Like if he has given it in MIT, if he could use it in Caltech, it would have been very easy for him. In addition, he could have actually created extra material with the time that he has saved. So reuse is one big option for globalization of this e-learning environment. Similarly, let's say if there are researchers collaborating and working on the same topic or the same research idea, it would be best if they could correlate or collaborate with each other, even if it is across the globe. Somebody in Israel wants to do Zurich, for example, IBM Zurich labs, wants to do something with the CERN lab. If that particular researcher can actually share the material as well as the resources that CERN can offer, it would actually help the whole research lab a lot more rather than going to CERN physically and doing his research work. So this kind of sharing is enabled only if the systems, the e-learning or the educational systems, can talk to each other. Now, that talking or communication can only take place if they all speak the same language. For example, if I start teaching this particular webinar in some other language like Chinese, not many of you would really understand. So it would be a waste of the entire effort. So the applications also, the e-learning applications should also try to speak the same language. They did not have the same language to speak. Some were created on Corba, some were created on .NET, some were created on Java. There was a lack of a design model for organizing these materials. Then the selection and distribution of this learning material was also different for different types of systems. For example, the system created by me would be something totally different. It would be implementing the LMS in a different way to something that has been done by someone else. There were various standards that were being used as per immediate and required need. There was also a lack of implementable architecture to define how to combine the information with the component models. And these solutions were all localized, as I just explained. So these localized solutions were not really conducive to global collaboration. There was no global library, there was no global repository of courses. That is when the thought of globalization of all these e-learning architecture came into existence. Several institutions came together to form a collaborative effort where they wanted to provide standard specifications, which means all the systems had to comply to a certain standard. For example, they will agree to a specific kind of system, and these were the minimum kinds of collaborative standards that each e-learning system has to follow, or else it will have the risk of being isolated. Also, they should make provisions to be interoperable between the information systems and the underlying platform. Your platform could be anything, but the information you provide or the information you require from other systems should be globalized. Now, this should seamlessly integrate component architecture and the heterogeneous systems with the information model. Now, we also wanted to propose an open or closed distributed architecture. Not everybody would like to develop their own applications. Some might want to use open architecture also. So it should work, whatever global standards that we are bringing should work with open or closed distributed architecture. Now, we also needed to identify common software services which are mandatory for such an e-learning domain. Now, in this webinar, whenever we refer to the information model, we refer to all the learning objects that are required to deliver an educational content. And whenever we refer to a distributed architecture or some heterogeneous system, we refer to all the underlying architecture or the system that runs these information models. There were certain limitations to all this collaborative effort of e-learning platforms. Now, in this webinar, we cannot, the scope is limited, we cannot talk about web-enabled multimedia systems. We do not talk about cloud-based document management systems or educational systems. We do not include semantic web search or relevant web search. So we are eliminating knowledge discovery systems. We need more time and in fact more educational content before we go on to talk about this. And this webinar also does not touch about digitalization procedures of various learning objects. When we mean digitalization procedures, we talk about there are a lot of paper-based material existing currently. A lot of documents which are archived in various libraries all over the world, which need to be converted into a digitalized format, a standard digitalized format, to be actually put on the web or the e-learning platform. The organizations who have taken up the initiative is IEEE, US Department of Defense, European Commission and UNESCO. The topics covered in this particular webinar will be a hybrid learning architecture for multimedia, an e-learning pedagogy, a functional architecture to build a standardized, standard-driven, distributed and interoperable learning system. Now, starting off with the web-based training technologies. The range of web-accessible technologies and services which are useful to learning are classified today broadly into 3 categories. These are infrastructure, which is specifically purposed to support learning, education, and training, where the systems are brought together specifically for a certain purpose of education delivery. Secondly, we look at infrastructure that is not specifically purposed to support learning, but has been enabled to do that in addition to the other functions that it supports. This could be in many organizations where the documents that are existing, the trainings that are existing are actually put on an intranet so that all the employees can access it and do some self-training courses. Then there are the more widely deployed infrastructure that may be useful for learning, education and training. This could be internet-based, it could be something like intermittent webinars, or it could be intermittent training sessions involving internet and other such tools. But this is not a dedicated platform. So we are going from the localized and the particular specific e-learning platforms to the global or the generalized platforms. There are other models that exist today all over the world. These are called the generalized functional models. Some of them are defined by SCORM. For example, any LMS that you pick up nowadays on the off the shelf are usually SCORM compliant. The one feature that they keep highlighting is that we are SCORM compliant. Why? Because SCORM is one feature which is now globally accepted. Then there is the functional model, which is defined by Sun Microsystems, that is applicable to all the Java specific systems. They have also come up with interoperable standards and a lot of other good work which has been done by Sun Microsystems. However, it is not followed by all other platforms that do not use Java-based systems. Then there is agent-based online learning systems that integrate software agents and learning object technologies. For example, they take existing applications off the shelf, they integrate it with their own learning objects or LMS, and then they create an educational delivery system. These are the existing models just now in the global scenario. What we need to do is actually bring these together and form a collaborative model amongst these. We cannot ask all the universities to change their systems overnight just so that they become collaborative. So what we need to bring about are certain standards which are applicable to all kinds of varied systems which are existing in world today. Sun Microsystems has done quite a bit of work in this. It has come up with a white paper on standards for interoperable systems. Okay, and these have been recommended to use Corba as a supporting infrastructure. This is one example of a COM collaborative model. If you see, there is a client which accesses the server through internet, and it's not necessarily a secure channel. It could use HTTP, it could use FTP, it could use TCP/IP, it could use anything that is suitable to it. So whenever a developer or a learner comes and gives a request, it is processed through intranet, and then it is taken from the server and then delivered to the learner. There are certain issues with the e-learning platforms. For example, there is a failure of interoperability. These are not scalable, and they are neither secure or they have administrative issues, which means when there is a great body of students who wants to actually access the learning objects through the internet, it becomes a bottleneck for everybody to access at the same time. So these systems are not equipped to handle great masses. They are not equipped to be extremely secure. They are also not equipped to deliver online content in the same category as classroom teaching. Even till date, students prefer to go to a classroom and learn from a teacher whom they can see, whom they can talk to, rather than access these e-learning systems. So now what we are trying to do is overcome that limitation. The proposed model that we are going to discuss, it divides learning system into LCMS and LMS. LCMS is Learning Content Management System, and LMS, as you all know, is the Learning Management System. Now, this model also divides the functional roles of each component. It covers all types of e-learning functional components and not just SCORM compliant models only. It also defines the permissible set of learning objects exchanged between each component. When we say we define the permissible set of learning objects, we limit actually the kinds of learning objects or teaching materials, otherwise it is called, to a certain standardized ones. For example, you cannot have all kinds of documents which are being given to the students as learning objects or reading materials. They have to actually comply certain standards. So, for example, if you have a document in LaTeX or doc or RTF or some other such document format, you cannot really share it. We restrict it to be shared with other users for security, administrative, as well as collaborative reasons. Nowadays, the document formats that are more popularly being shared collaboratively are the EPUB formats, the PDF formats. Amazon, of course, has brought its own Kindle format. Microsoft similarly has its own MOCs. These are all existing in their own worlds, but you cannot really run an EPUB on Kindle or an MOC on any other reader. You need specific readers to access this digitalized content. This again limits everything. So in this proposed model, we try to bring a collaborative effort of standardizing these 4 or 5 kinds of documents, limit them to these 4 or 5 kinds so that there won't be more such kinds of digitalized documents cropping up, which will just form a list of documents which again require specific readers on which we need to read them. A generalized managed learning architecture would look like this. We have a virtual learning environment, which is here. Then there would be a portal through which the student or the learner would be accessing all these learning objects. If required, there would be a learning management system and the student records or MIS and such administrative part of the learning architecture. So whoever is enrolling into this e-learning architecture comes through a portal, accesses either the student records or the administrative services, the library management system where he can read or access archived material, digitalized material, and the virtual learning environment where probably the lectures are delivered through virtual webinars or chat sessions or even Skype or other mode. If we break this up into different portions, this is what a managed learning architecture would look like. The virtual learning environment would have something to do with content management, knowledge discovery engines, collaboration between systems, course management systems, Obviously, there should be some authentication so that these are not insecure. Authorization of which user can use how much of content, packaging and assessments. These are standard for all the virtual learning environments. Then we have a library management system, which again would have content management system, knowledge discovery system, cataloging system, course management system. Again, it needs to have authentication, authorization and packaging systems. Coming to student record management system, it will have grading and grade maintenance systems. It will have again a course management system, authentication system, obviously, and authorization system. If we look at it for a few minutes, any one of you might ask, why are we repeating certain procedures or certain applications? For example, content management is common in both virtual learning environment system as well as library management system. Why not combine both instead of having different content management systems for both the systems? We could similarly say knowledge discovery system can be commonized. Similarly, authentication, we require that across all three platforms. So every time a student logs into, let's say, virtual learning environment, he needs to authenticate his student ID and password. Again, if he wants to access the library management system, again he needs to authenticate his student ID and password. And if he wants to access any of his student records, again he has to authenticate his student ID and password. That's a headache for the student. Why not bring about single sign-on? Any one of you might be asking that. That's a very good suggestion. So why not take out these common functionalities and bring about something like this? So we still have three different systems: a virtual learning environment, a library management system, which is archiving all the course materials, and then there is the student record and administrative system. Only thing is, now we have separated the common systems or functionalities from all these three systems and put them in a separate box. When we look at it this way, we see that a lot of functions could have been actually commonized, and that reduces the load on the system. That also makes it more efficient. So we keep the specific functionalities like collaboration, assessment, etc. for virtual learning environment. Cataloging is something very particular only to the library management system. And then grading and grade maintenance and student record maintenance is something which is particular to the student record maintenance system. The rest are common to all of these. For example, content management, packaging, authentication, authorization, knowledge discovery and course management are common across all three platforms and hence have been made commonly available to all three systems. So this brings in a little more efficiency into the system of e-learning architecture. Now coming to other e-learning architectures, we find that the first generation of e-learning architecture has been passed. Most of the institutions are in second generation of e-learning systems, which means they have already implemented one set of platform and e-learning materials, and now they are upgrading them. So a lot of companies have legacy systems. When the need arose, they built whatever they wanted in whatever kind of infrastructure that was available to them. Remember, infrastructure is very, very expensive. For a company or a university or an educational system to invest in fresh infrastructure every time they want to upgrade their e-learning platform would be cost prohibitive. And I do not think anybody would really appreciate upgrading their system time and again just so that they can bring in a few new features into their e-learning system or document management system for that matter. So what they would prefer to do is keep the existing system and somehow bring about the new features. I'm sure all of you agree with that. We have all had at some point of our lives tried to reason with the management that we need a totally new system which is so wonderful that let's throw away the old system, but that doesn't happen. It's frustrating, but that is what we have to live with. So, thus was born service-oriented architecture. So you build on top of whatever is available. We call them plugins. So we build a new student portal which will be plugged into the student record system through course management web service, library management system which was maybe not existing as evolved as previously, and then there is a department of developed teaching tool. Let us say they bring in new tools, a new version of web meeting, GoToMeeting, so on and so forth. All these, when they get upgraded, they need to go back and work with the legacy systems that are already existing. So we develop some architecture or some application which can talk to the old systems. Sometimes when this is not possible, we make sure that we build a layer in between which would talk to the old systems. In this webinar, this particular layer that talks to the legacy system has been recommended to be web services. Why web services? Because web services is a universally defined language set of rules. It is accepted by other applications also, and it is also easily implementable. So this is one thing that is globally available. So we come to web services as a solution provider. Web services provides a standard means of communication amongst different software applications. Let these software applications be pre-existing or the new ones. They could also be running on different platforms for all we know. Now, the potential for web services for a combination of XML, SOAP, WSDL and the internet is immense, because the internet actually supports all of this, and most of the applications that are running nowadays also have been standardized to accept the web services. And then it's a common platform to a lot of other managed and unmanaged documents. One such platform is our internet. And then there are scores of intranets existing within companies which use XML, SOAP and other web services as a means to communicate and also put up documents. These are also tried and tested protocols, and they promote interoperability, they promote scalability as we see in internet, and they can be extended also. So these are the features that make web services a very desirable solution in order to have a collaborative environment in e-learning architectures. So that is why we decided upon using web services as a communicator. There could be both .NET and J2EE as a platform. We focus here on J2EE with no offense to .NET users. There are lots of companies which actually use .NET, possibly because it's freely available, more so because they might have been using Microsoft products, so they have to use .NET products, so on and so forth. It could be any number of reasons. So without any prejudice to one or the other, we discuss web services as a solution on J2EE as a platform. So here we look at some advantages that J2EE offers. Both J2EE and .NET support web services. However, J2EE platform offers a wider choice of vendors for platform, especially for application servers. It is also an industry standard which can be implemented across multiple operating systems. So there is no such limitation for an operating system. It is especially beneficial for J2EE based legacy systems. The existing J2EE components can be easily exposed to web services with a wider range of functions because it works interactively with the web services. So we decide upon J2EE as a platform with web services as a communicator service because of its portability, scalability, and reliability. Three of the features that we really require in order to bring about a globally collaborative e-learning environment. Let's look at the current e-learning interoperable standards and specifications. The interoperability standards are needed to provide standardized data structures which communicate these protocols for e-learning objects. When these are incorporated in vendor or commercial products, these become globally available to all users, which means there can be exchange of an exchange of information globally. Then there is a standardization and uniformity in learning objects also. Now this cannot be brought about just like that or overnight. There are several teaching materials or learning objects which have been developed with a highly specific reason in mind. All of these have to be made web services compliant, and as well as they should be globalized, standardized. The interoperability categories for standardization of these learning objects are bringing about a common metadata to mark all the documents or learning objects. The content packaging should have certain specifications which are common across the globe. The learner profile maintenance should also be standardized. The learner registration process can also be standardized so that anybody from anywhere can register into any system and access the learning objects. And finally, last but not the least, the content communication between the systems needs to be standardized. Once these 5 features of information model are standardized, we are ready to build a system which will enable the communication between teaching materials amongst various educational institutions. What is metadata? For any of you who do not know what metadata is or who are new to metadata, these are kind of indexing systems which label a document so that it can be identified. You might have noticed in your Google search or Bing search that you use certain words to search, and these are thrown up as keywords. Or when you are probably creating a digitalized document, you provide certain keywords. So these keywords are a way of integrating these documents with the global system. We are trying to tell the world that this document deals with this keyword. For example, if I am uploading a document on Java J2EE or let's say patterns, design patterns, I will include design patterns, Java, J2EE in my keywords. So whenever somebody searches for design patterns, my document is caught and thrown up in their search. So indexing forms a major part in making your document available to a learner. What metadata does is it commonalizes or makes a common ground or platform for marking a document. So we need to bring about a support for global indexing. This indexing could also be for storage within the organization or archiving. It could be used in a library system or it could be used in a local intranet in a company. But all these documents should use the same metadata. Why? Because what is available in a global library can tomorrow become necessary for a company to access it. So if they speak the same language, the same indexing language called the metadata, then it will be easier to collaborate. Now this metadata should also support knowledge search. It should not only throw up your document in any common search, but it should also enable the related documents to this particular document should also be caught in the search. For example, if somebody is looking for same design patterns, Java, J2EE, they should also be given some more recommendations. Okay, so you are looking for design patterns, you might also be interested in learning about factory model, or you might also be interested about learning about web services. So these are related subjects to J2EE and design patterns. So a document should not only contain keywords, it can also contain a field which says, okay, this document deals with not only design patterns, amongst which factory model is one such pattern, it also deals with web services. So if you are pulling up this document in a search, you might also want to read about web services. You might also want to read in depth about factory model, so on and so forth. So this is how your search is recommended. This is most appreciated when we are looking for directions in a map online, or we are looking for movies to go to. So if it is not, if a particular movie is not available at a particular time in a particular theater, the search should enable that, okay, this movie is available at this particular slot in another theater which is nearby to your theater. That would be really appreciated by a lot of us when we are searching for a movie to watch. So this is what is brought about by a standardized metadata. It enables knowledge search and discovery. In fact, what I told you just now is a tip of an iceberg. It has a lot of in-depth knowledge, and we need to go very deep into this in order to really explore this and bring out its potential. Metadata is also required to support the retrieval of learning objects across multiple tools and multiple types of repository. All of them, if they speak the same language, they will bring up the same kind of material instead of just throwing documents at the learner haphazardly. So in order to globalize this indexing system, the organizations have come up with certain standard indexing systems. The two most prominent indexing systems used are the DCMI, Dublin Core Metadata Indexing System, and the IEEE Metadata Indexing System. Okay? So these two are actually interrelated also. They are not so different from each other, so that they can actually pick up documents which are using the other indexing system also. For example, if your document is using DCMI, a system that is based on IEEE metadata indexing system can actually pick up these documents in its search. This is very useful for search and knowledge discovery in libraries, global libraries, or we can use this to implement one big global library of digital documents. Next comes the way we package the content. The content packaging should allow courses to be portable from system to system. In a lot of cases, the company itself might actually change its system midway for various reasons, business reasons or system reasons or infrastructure reasons, and they need all their content to be portable to the new system. If we have a standardized content packaging, this is easily done. However, if we have a legacy content packaging or something very particular to our own company so that it is highly secure, this becomes a headache and a bottleneck. So a company has to decide, a company or an institution has to decide a proper balance between how secure its documents are and how globalized and collaborative the documents are. One of the commonly recommended packaging system is SCOM, Shareable Content Object Relative Model. Lots of people are using this, but there are other content packaging systems like the IMS, which has actually been implemented long back and which collaborates with SCORM compliant learning objects also. Which means even if we have a few different kinds of packaging, they can all collaborate with each other. The uniform format range has to be uniform standardized across all learning objects. We should start using standardized formats for different kinds of learning objects. When I say learning objects, I mean images could be learning object, a document with a text can be a learning object, a video could be a learning object, an audio piece could be a learning object, anything. So the recommended formats are use vector graphics or SVGs for images instead of compressed graphics like JPEGs and PNGs. Even if you have such images, you may want to try to convert them into vector graphics, or in case that is not possible, the next best option is PNGs. Again, audio recommended is MP3. If you have RAM or other audio formats, that's fine, but if you can convert them into MP3, and you get a lot of converters nowadays, the effort is actually trivial and the benefits are multifold. Similarly, MP4 is recommended for videos, but then AVI is more popular, as we all know. There are certain examples for this standardization. For example, IMS is a simple sequencing methodology. ADL's SCORM is again another popularly packaging model used across all platforms. We are actually looking at the standardization of learning objects, so that once we standardize the learning objects, we can then start building systems which will standardize the communication between these learning objects. So those of you who have joined in late, we are looking at standardization processes for teaching materials or learning objects. Now, the next thing we come in the sequence is the learner profiling. The learner profile information could include personal data, learning plan, session plan, performance history, etc., etc. All these also need to be standardized. Standard is being brought about by IEEE. Next comes learner registration, which allows the learner profile graph. It indicates learners' requirements and prerequisites. For example, somebody who has not taken Java 101 might need to take Java 101 before he can jump into a master's course on Java J2EE. So these are captured in a learner registration system. It also gives an idea of learner preferences. Let's say a learner wants to combine history with computer architecture. Why not? So these preferences can also be captured. And based on these preferences, the student is then recommended certain courses, recommended certain reading materials, etc. Again, IMS has brought about some enterprise specifications and schools interoperability framework, which again we need to go into detail, which cannot be done in this particular webinar. Then we come to content communication. The content to be launched according to the learner requirements has to be standardized so that the learner data to be communicated is actually stored in the systems before the course is launched. For example, if one student wants to take up A, B, C courses, his preference is already recorded in the system before the launch of the course. And student B can similarly have his own preferences. So these courses are tailor-made according to the student preferences. So the courses are no longer standardized. A student does not go to a course, but the course comes to the student. Also, the content type needs to be communicated to the systems before the content is ever scheduled, so that the system verifies that the content is actually standardized content and can be broadcast from the system. The system or content compatibility check has to be done by a system before a course is launched. Again, IMS, ADL's SCORM, CMI, these are all doing a great job in bringing about the teaching material standardization. Now we come to the functional architecture, and we will discuss the standard-driven distributed architecture and how to make them interoperable. What is this functional model? Our functional model, based on our previous discussion, should provide a visual representation of the components of an e-learning system. It should also draw a visual map of the objects to be drawn across these systems. It should track the learning content as per the learner's profile. As I just explained, each learner's profile is stored, and a course which is tailor-made to the learner's preferences is given to the learner or the student. And this functional model is also influenced by standardized models such as COM and IMS. Because we cannot change legacy systems overnight. So these standards are drawn upon what are being commonly used in most of the institutions. Instead of asking all of them to change, we drop some standards based on what is generally in use and then provide some recommendations. In addition, we divide the functionalities between a learning management system and a learning content management system. In the future slides, we will see what's the difference between the two. What is the advantage is splitting them into LMS and LCMS, it focuses on separate functionalities. It clearly defines each of these components functionalities so that one is student facing or client facing and the other is process facing. A standard functional model can be represented in this way. There are, let's say, content experts or SMEs, subject matter experts. There are teachers, and then there are users. Users, we refer to them as learners or students. Now we have divided our system into LMS, which is on the right of the screen, and LCMS, which is on the left of the screen. One might ask, what's the difference? And LCMS actually enables the content experts or the creators of the content to develop the content. It not only distributes the content, it also has the capability of allowing the creation of content. Now, a student doesn't need this because a student is not creating a content. A teacher may also not need this if a teacher is just teaching the content. But a content creator needs to have this functionality. So that, let us say we have a book on physics, but tomorrow it needs to bring about a second edition. What do? Do we take out a second book like we do in printed formats? There's a better way to do it. We just push in the upgraded material at the requisite place. Now this can be done or enabled by the LCMS, Learning Content Management System. So it provides content authoring tools. It also provides content assembly tools. As we had discussed earlier, different students might have different learning profiles or different learning preferences. Let's say a student, let's take the example of the student who wants to combine history with computer architecture. So this learning content assembly tool will create the course for the student where it will take content from computer history or other histories and computer architecture and forms a course for this particular student. Now, an LMS cannot do this on the fly. Then there is remote service which is provided by LCMS, which enables experts from anywhere globally, literally sitting anywhere in the world, to access the system so that we can actually delve deep into the talent pool that is available globally in order to enrich the learning content. So you can have your experts logging in from anywhere and authoring your learning content. The Learning Content Manager now integrates the content authoring tools and assembly tools. It creates a course in its repository, content repository. The tracking engine actually tracks which course is being utilized let's say, all the data mining of how the course is being utilized, how popular it is, how required it is, so that we get a feedback, or the institution, educational institution gets a feedback on how effective each course is. And finally, we come to the delivery environment. So LCMS, once it integrates subject matters, course material, and assembles the course, it actually delivers it to the LMS. Now, once it goes into the LMS, the teacher may have limited course authoring. Definitely, the teacher can change the learning plan, because we can't have a rigid learning plan. It will have its own course manager, so that in case of emergencies, if you need to change the course a bit, the LMS can be allowed to do so. And then it will have a collaborative environment, and then it will manage the learner profile. Based on the learner profile, it will distribute the courses. The LMS will also be having the learner registration manager within its scope. And in addition to all of these, in cloud-based e-learning systems, we might want to introduce the remote service. So this is the functional model proposed for LCMS and LMS. Next, we will see how these will communicate with each other. As we had discussed, an LCMS is a multi-use environment. The learning content developers can create, store, reuse, archive, etc., all the digitalized content. LMS also manages processes around the learning objects. But LCMS manages the creation, reuse, and archive of these courses. And finally, it delivers it to the LMS. The functional model also separates LMS and LCMS very clearly in giving them each a role. It sets up creation and communication standards to make sure there is no confusion. It also allows multiple tools and repositories to communicate with it, so that learning content is seamlessly distributed to the learner without any disturbances. And the interoperability between LMS and LCMS is established using web services, which is what we see now. Now, how do we use the web services in a learning environment? The service architecture that I'm going to show you, it describes the web services used for communication. Now, this is only one kind of model. You can also have your own kind of model to bring about such a communication. But this shows the basic standard communication architecture that is required, that is mandatory in order for global collaboration. The information is exchanged between learning objects, IMS content packaging or COM content packaging, and all have standard XML bindings. That is what allows a standardized exchange of information. The web services architecture is platform and language independent, as we all know. And it also provides a uniform programming model for intranet as well as internet services. It doesn't really differentiate whether it is intranet or internet. It doesn't care. It treats both of them equally and distributes information as and when required. So this is a standardized web services architecture. You can build upon these to bring in more specific kind of services. Rudimentarily, what it has is one LCMS where certain protocols are established which need certain kind of communication services, an LMS which needs its own kind of communication services. Then there are clients and service providers. Let's look at the LCMS service architecture. It has content service requester and provider. It could be the same web service, or you could have separate web services for both. LCMS also houses the learning service requester. Now, when an LMS requires some kind of learning content, it sends a request to the LCMS saying, look, I need this particular object or this particular document from this particular course because this particular student has the requirement. Then LCMS looks at its own course, sees if it is upgraded or not, and then once everything is verified, it sends it to the LMS. LMS in itself distributes it to various students as per their requirement. It could actually send to remote LMS. For example, MIT requires some document from the library in Alexandria or the New York City library. So it sends a request. The LMS in MIT sends a request to the New York City library saying, I need a certain document. So New York City library, which archives a lot of the documents, searches for these documents, looks for its verification, makes sure it's the correct document, and sends it to the LMS. Now this particular MIT LMS might want to send it forward to the Virginia State University. So it will send it to the LMS at Virginia State University and say, okay, you can also take this because I got it from New York City library, and it shares it with other LMS. So this is how collaboration is done across the globe. Now what I had taken as an example was within one country. This is quite possible within across countries also, across continents also. Similarly, let us say a user is trying to put in, a researcher has put in more material on a particular topic. This content which the researcher has presented as a paper needs to be digitalized. So where does he send? He will go to a remote authoring tool. He will log on to, let's say, New York City Library authoring portal and says, okay, I have brought up a new research paper and I want it to be archived in the world's biggest library so that everybody can access it. So he is given a remote authoring tool access where he uploads his document. That document is standardized, content-wise, package-wise, as well as make sure that it complies all the teaching material standards, and then it is put into the library archives in the New York City library. Now, as soon as this is done, the addition of this document is published to various universities or interested parties. Once they see that such a new document has come into the market or come into the library, they might want to access it, and then they will send a interaction or a service requester, and this service is provided to these institutions. So this is how a scientist, maybe sitting in Israel, can publish his paper to a library in New York, which is again distributed in a university in Boston, and then sent to another university, let's say in China. This is global collaboration. Now this can be across multiple libraries also. Different components exchange messages through interaction of web service agents in each system. System provider is the platform that hosts these access to the service. This is also known as a service execution environment, and its role in a client-server message exchange pattern is that of a server. So some of them act as servers, some of them act as clients. The same client can become a server for some other access point. So this is how our global connect or global collaboration takes place through a web service architecture, where a service is requested through a service requester, and a service is provided through a provider. A service requester initiates the communication for a service request. A discovery agent is a discoverable set of service descriptions where service providers publish their service descriptions. What a discovery agency is, for example, in a library, in the example I just described to you, if a new research paper is added or a new teaching material is added, the library actually makes sure that it is upon the list of new material available. This is constantly scanned by other universities or interested institutions. Once they see that, oh, something new has come up, they actually request for this new material. It's just like publishing in a paper that, okay, a new movie is being released this Friday. and you advertise in the paper. Once we all see the advertisement, we all try to go and book tickets for this new movie. So that this explains how the collaborative effort takes place digitally. The service discovery agency or the knowledge discovery agency can also be centralized or distributed based on the business strategy requirement. For example, within a company, you don't really require a lot of service discovery agencies or a huge library. But then something like a New York City library or the Alexandria library, they actually work as distributors of learning material. So they might have multiple or distributed service discovery agencies. So this describes the web service architecture. The learning information is presented by XML, which is wrapped in SOAP specification, and it is now exchanged between the requester and the provider. This is how the communication takes place. Since this is a standardized process across all learning objects and this is a globally followed procedure, the language spoken is universal, so it has no borders. So every system which uses implements web service architecture can communicate with every other system anywhere in the world which implements the same web service architecture. The provider now publishes a WSDL file that can contain the description of the message, and this allows the requester to generate the SOAP message and send it to the correct destination. This is like any other service architecture that we are using between application, collaboration between applications. So this is actually no different from other collaborative environment that we are creating. Only thing we are doing is we are standardizing the teaching material and then we are standardizing the communication platform or the service architecture. Standardizing both will make sure that everybody in the world can communicate and access the wealth of information available all over the world. Now we try to implement it using J2EE. The architecture described here is just one kind of architecture. Each company might want a different kind of architecture, but then the final communication between this architecture and the service architecture should be common. So whatever system you bring in, you can replace it with .NET system also, but it needs to be communicated properly. The outside communication should be standardized. That's when it will be effective. We see that it's a three-tier architecture. The bottommost layer here is the EJB or the servlet architecture. The middle layer is the servlet architecture. And finally, the top layer is the JSP architecture, JSP layer. The lowermost layer or the data access layer may contain beans. Here what I have shown is the EJB beans, where it will access the learning content using SCORM compliant model beans. And then these data model beans are actually picked up from the database, and according to the requester, they are sent to the client. The servlet layer serves in serving the content and processing the requests. The servlet layer also has a content management control, which controls which content is going to which particular user. We can have different types of users. The different types of users, as you can see on top, are learners or the students, content experts who are the subject matter experts, and teachers. So the servlet layer here decides which content should go to whom. It also sorts the service requests so that not all services provided to all users. They can certainly request for services, but not every service is provided to every kind of user. The delivery control, most of the controls in fact, are stationed in this middle layer, the servlet layer. And the tracking of these controls are also stationed in the servlet layer. The The front end of this system architecture is the JSP layer, which actually takes the request, processes the request, and provides the users with content delivery, etc. It handles the secure login, secure content delivery, etc. All this is done obviously with the help of the middle layer. Now this is a broad explanation of a J2EE architecture. The same which is provided in this gray box can be replaced with .NET architecture and still made workable. That is the beauty of a collaborative environment. What we discussed today is something particular to J2EE, implemented using web services, using standardized teaching material or learning objects. So we have broadly divided our e-learning system into 3 parts. The learning content, which is standardized, the service architecture, which is again standardized, and the underlying platform, which can be anything, the legacy system, so long as it complies with the service architecture. The LCMS architecture using this J2EE and web services has components in the functional model. These are distributed into different layers. That is the advantage that we bring to this. The components with similar functions in the same layers are combined and provided to the upper layer or the layer above it. This model promotes a model that anticipates growth. This can be easily changed also, as we all know, and it also encourages component-oriented code reusability. It leverages the strength of the interlayer communication technique. And the tier integration is easy, and which is also the strength of this model. In conclusion, what we have seen in this webinar are we analyze the need for a common e-learning system. We proposed a model which divides the e-learning system into 3 logical broad categories: the learning material part, the underlying system platform part, and the middle communication part. We also define the different learning objects that are exchanged or allowed to exchange between each component. Not every teaching material is accepted. Similarly, not every platform can be accepted. And the web services is the glue that provides the collaborative capability for the platform using these standardized learning objects. That is what we conclude our webinar discussion with. I would like to take your questions now if you have any. Okay, there is one question here which says document management system anyhow exposes all LOs as URLs for access. Okay, so what is the question? I'm sorry, give me a minute, please. Okay, there are quite a few questions here. Let me take them in order. How many LMS and LCMS are required if a document has to be shared between 2 institutes? For one document to be shared, you only need 1 LMS and 1 LCMS. But then, it also, as I explained, if it's a huge institution like a library, a global library, you might want to have several LCMS or a huge LCMS with the capability of processing a lot of documents at the same time in order to collaborate. I hope that answers the question. Now the second question is, if the large content, say a video file, is shared through web service, doesn't it become a bottleneck? Is there any standard for sending compressed content quickly? Yes, there is. It does become a bottleneck if we send it without a media server. So in our platform, we integrate media servers also. Nowadays, you get quite a few specialized media servers like the Windows media server, the Adobe media server, which do an excellent job of compressing and decompressing your videos, which can be several megabytes or even gigabytes. They are compressed properly, and you can actually adjust your compression settings according to the transmission rate. So media servers are commonly used in the collaborative environment as well as in the e-learning system platforms to serve these heavy videos. If you go to Netflix architecture, Netflix is, for those who may not know, I'm sure every one of you knows what Netflix is. Netflix is a movie serving portal. They not only deliver DVDs house to house, but they also stream their content live through either Xbox, which they have collaborated with Microsoft, and they also provide online internet streaming so that you can log in and watch movies online, and there's hardly any disturbance. That is because even if you are in India and are streaming from Netflix, they have several servers at several places which stream the content seamlessly to your laptop or desktop or wherever you want to see. Nowadays, with the TVs being smart TVs, you can actually connect your laptop or your CPU to your TV and watch movies online without any disturbance through Netflix. So this is one video portal which sends huge video files. Movies are video files through web services, and it does not become a bottleneck because they use media servers. Does that answer your question? The next question is, in infrastructure terms, how does this system differ to IaaS cloud computing? We are not talking of cloud here at all. When we are talking of web services, we are still talking of internet. Cloud is something where you put it in it's a generalized environment of this localized environment. So we need a different kind of webinar to discuss cloud-based systems. Coming to the next question, in organization learning environments where the learning object is or are on the document management system and the LMS acts as a smart facilitator for the learner and trainer, wherein the learning object can be accessed via a URL mentioned inside the LMS, is interoperability a concern here? Yes, it is. If you have branches of the same company, the trainer is sitting in one place and the learner is sitting in a different region of the globe, interoperability can become a major bottleneck. Since the document management system anyhow exposes all LOs as URLs for access on the intranet. We are talking of the intranet here. But then even within the intranet, do you need to publish it as a URL? We don't need to if we have web services. And we are talking of only documents here. Next question again from Mr. Raghavendra. In infrastructure terms, how does this system differ to IaaS cloud computing? I think I answered that. We need to discuss this in terms of cloud computing environment differently. So that seems like all the questions I had. If you have any further questions, you can all actually write to me at jshritangirala@hotmail.com or send them through the moderator. Thank you all for patiently listening to this. If you would like elaboration of any of these topics or furtheration of this discussion, do kindly update it on TechGig profile, or please indicate it to the moderator. I have another question here. If the large content, say video file, is shared through, okay, I think I have answered this. So I think that ends this webinar, and I'll hand over the mic to the moderator.
Well, thank you so much for the wonderful presentation, Jayashree. I'm really thankful to you for conducting this webinar and also answering all the queries of our attendees. It was a great session. I would also like to thank all our participants for the support in making this webinar a success. The recording of this session would be available on techgig.com by evening. Thank you all. Have a great day.